Okay, we're on 1.6, exponential and logarithmic functions. I am going to do the first half today, exponentials and the number e. Then we'll go to the next video, logarithms and some applications of those. So an exponential function, don't forget to put the fun in functions, is of the form y equals b to the x. B is greater than 0, and it cannot be equal to 1. It cannot be equal to 1 because that function is linear. Okay, so it wouldn't be an exponential, actually. Okay, here's some properties of exponential. Let's graph y equals 2 to the x. All right, so 2 to the 0 is 1. 2 to the negative 1 is 1/2. Third, etc. And 2 to the first is 2. 2 squared is 4. 2 cubed is 8. So you can see these accelerate very quickly. They increase very quickly. Okay. And then if we do just another fine example, half to the x, it's actually going to be just the opposite, reflected around the y-axis is what we would say. Two, 4, 8. Okay, so notice those two are reflected around the y-axis. Look at the difference here. 2 to the x increasing, half to the x decreasing. Okay, the domain is all real numbers. Okay, but the range of each of these is only 0 to infinity. Okay, or you could also write it instead of y such that y is greater than 0. Okay. So that's one property you need to remember, and we talked about this. So it's increasing if b is greater than 1, decreasing if b is between 0 and 1 if it's a fraction. Okay. And the range indicates that it's always positive. Okay. We can move these up and down. We can translate them up and down, but for now we're just looking at the basic case. Okay. Let's look at the properties of exponentials. Exponents. Okay, by far and away the most important one. If you multiply those two with the same base, you're adding the exponents. Okay. So an example here, I have 3 squared times 3 to the 4th, I get 2 plus 4. Okay, so multiplied, same base, means add exponents. We're going to run into a lot of others that you just have to be automatic. Anytime a power is raised to 0 or an exponent is 0, the answer is 1. Okay, we have the product, 0, about quotients. It's just the opposite of multiply. Okay, if you multiply these together, it means you add the exponents. If you divide, it means subtract. Okay, negative exponent. So if I have a negative exponent here, it means drop it underneath. Or if the negative's on the bottom, it means bring it up to the top. So basically that's just telling you do the opposite. Okay. Power to a power means multiply the exponents and roots. Okay. If you want examples of all these, I think that one's good. Let's just do one here. Let's say B, let's say this is 64 to the 1/2 power. Okay, that's the same as, see, this is their n, right? So that's what goes in the root. And in fact, that's actually just the square root of 64. Okay. So be aware there, the 1 would actually be right here. So if you have fractional exponents, you know, the top number goes with this, the bottom number goes in the root. Okay. There are some more examples of those on your book on page 44. Example 1. Let me give you some of them. You can do compound. Let's say 16 to the negative 1/2. That's the same as, so it's a negative exponent. We're going to drop it underneath. And it is also a square root. So in fact, we get a 4th. Okay, that half tells us square. A third would be a cube root, etc. About 27 to the 2/3. Okay, that's the cube root. 3 goes in the root. 27 squared. You can do those in either order. Okay. The cube root of 27 is 3. Okay. There is also another way to do this. You can do 27 to the 1/3 squared. Okay, 27 to the 1/3 again, 3. Lots of ways to manipulate these. Just take your pick. Okay. Some of the more important situations you'll run into is solving equations. You're going to have to solve a lot of equations this year. I always say calculus is where you learn your algebra. let's just go to A. Okay, same base. What do we have to know about the exponents? That they equal each other. Okay, so we can just do that. You subtract 1, divide by 3, I think you get x equals 4/3. All right, let's try another one. We're going to have to manipulate this one a little bit, I think. Let's raise each side to the 1/3 power. All right, so 3 to the 1/3, 3 times 1/3 is 1, so that gives us b. And then 6 times 1/3 is 2. We get b is 25. Okay, just kind of have to think through those sometimes. Okay. What I want you to notice is that this is 7 to the negative 1. Okay. So it's 7 to the first here on the bottom. When you flip it up, it becomes negative 1. That was one of our properties. So what I have is 7 to the t plus 1, and then 7 to the negative 2t. So t plus 1 equals negative 2t. 1 equals negative 3t. And negative 1/3 is t. Circling our answers because it's nice. All right. Finally, the number e. You're going to love the number e. You would say, hey, that's a letter. Yeah, it's a letter, but it's also a number. It's kind of like pi. If pi is irrational because it is a non-repeating, non-terminating decimal. Well, so is e. 2.71828, yada, 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 both irrational. Okay, they're both very special numbers in mathematics. Okay. Very special, and you'll see why with logarithms and in the next video. But the graph of e to the x. And one of the beautiful things about these exponentials, they all have a y-intercept of 1, unless you translate them up or down. Okay. E to the first is e, so that's 2.7. Oh, that's 2.7. Cross that one out. 2.7. E squared. Anybody off the top of their heads? About 7.3. Somewhere in there. And then it's gonna come down somewhere in that area, approximately. Okay, so just for now, know that it's a very, very special number. You're going to have to use it a lot. Okay. Part of the unique piece of this is you're going to learn what these are pretty quick. This is what's called a tangent line. It touches once. The slope is 1, and the equation
is y equals x plus 1. Those are very special. Okay, tangent lines are very special. So that's what we call a derivative. The derivative gives us the slope. The tangent line can give us a lot of information. Okay, so just be aware of that. 1.6a, the work I am asking you to complete. 1 through 9 odd, 31, 1.157, 1.52, and 4. And then if the next video, we'll go over this. But this is what was addressed today. This is what we'll address tomorrow. These are both due in a couple days. We'll have a couple days of work time in class. Thanks for watching. Toodles.